Hello, this is Mr. Underkoffler, and today we're going to be looking at guided notes on slope. So what is slope? Well, slope is the following ratio, and you can look here on the box on the left. Slope is a fraction. Ratios are written as fractions, and the numerator of that fraction is called the change in y. The denominator of that fraction is called the change in x, and that equals slope. Now, the variable for slope, I did not pick this, so don't get upset at me if you don't like this, but the variable for slope is m. M stands for slope. And so to make sure you understand what this means, change in y, think about a coordinate plane. Y is going up or down. Change in x, the direction of x goes right or left. So I drew these little arrows here for you to help you to understand what I mean when I say the change in y, that means going up or down. Change in x means going right or left. Now, you're going to hear a lot of different mathematicians across America. They'll use another phrase for this ratio. Instead of calling it the change in y over the change in x, they might just call it the rise over the run. All right, that's another way of saying it. I'm not going to use that throughout these guided notes, but you will hear a lot of algebra teachers across America use that terminology. Rise over run means the same thing. Rise means going up or down. Run means going right or left. It's the exact same thing. Now, what's the purpose of even doing this lesson? Who cares about slope? What's the purpose? Well, I explain that over here on the far right. The slope of a line tells us how steep the line is. So the greater the slope, the steeper the line. The smaller the slope, like if it's a fraction, a very small fraction, then that means the line's not going to be very steep at all. So we'll be seeing examples of this throughout these guided notes. All right, we're going to start by looking at how to get slope from a graph. There are 4 very simple steps that I'm going to follow on the examples I'm going to show you here. Feel free to hit pause in the video, read these steps to yourself, then hit play when you're ready for me to move on. All right, here we go. First example, you can see we have this diagonal line. I drew it in red, and I have shown you 2 dots that this line will go through. What we're going to do is we're going to start at one of those dots. It doesn't honestly matter which dot you start at. In fact, I'm going to prove that to you by doing this problem 2 different ways. So I'm going to start by looking at this dot here in the bottom left-hand corner. And starting at that dot, we're going to count how many spaces we need to go up or down. In this case, we're going to have to go up. And then how many spaces we're going to have to go to move to the right to get from the one dot to the other dot. Now, when I say spaces, let me make sure you understand what I mean here. Let me highlight this in blue for you. Now let's go with purple. This right here is one space. Here's another space. Here's another space. Here's another space. So this is a total of 4 spaces going up, and then 1, 2, 3, 4, 5, 6 spaces going to the right. And that's why you're going to see, using the definition of slope, where the numerator is the change in y, the denominator is the change in x, we went up 4 spaces, so that is a change of y of going up 4. The change in x was going to the right 6 spaces. Now, we have to understand which directions are positive and which directions are negative. When you go up for your y, that's a positive. If we would go down for the y, then that would be a negative. So since this was up 4, that's positive 4. For the x, if we go to the right, that would be positive. If we go to the left, that would be negative. So since we're going to the right 6, that's positive 6. And then the very last step that you do is simplify your fraction. 4, 6, they are both divisible by 2. The 4 and the 6 are both divisible by 2. And so that would reduce to 2/3. And that is the slope of this line. Now, you heard me say that it doesn't honestly matter which point you start at. I'm going to prove that to you here. This is the exact same line I was just showing you. But this time, we're going to start at this point here in the top right-hand corner. So this time, we're going to have to go down 4 spaces and then left 6 spaces. And so again, the definition of slopes, change in y over change in x. So the change in y would be down 4. The change in x would be going left 6. But when you go down 4, that's a negative 4. When you go left 6, that's a negative 6. But this is still going to equal positive 2/3. Now, how did it all of a sudden become positive? I explained this to you in this little information box underneath. Why did the fraction become positive? Because fractions technically mean division. And we've learned about that earlier this year. The fraction bar actually means dividing. We don't normally always think of it as division, but that's technically what it means. And we learned that a negative divided by a negative will equal a positive. So anytime you have a fraction where the numerator and denominator are both negatives, that will simplify to a positive, because a negative divided by a negative is a positive. And so I've just proved to you, no matter which point you start at, this line for this first set of examples, no matter which point you start at, it's going to have a slope of 2/3. Now let's look at another example. And again, this is already typed up for you on your guided notes. On this example, let's start with the point up here on the top left. I would have to go down and then to the right to get from the point up here on the top left to the point down here on the bottom right. So let's count. How many spaces did I go down? I went down 7 spaces. How many spaces to the right? I went to the right 3 spaces. Now remember, make sure you put the correct numbers in the correct places. The numerator is always the change in y. The denominator is always the change in x, or rise over run, as many algebra teachers across America like to call this. So that's why the numerator was down 7 and the denominator was right 3. Down 7, is that positive or negative? Well, if you're going down, that's negative. Going right 3 would be a positive 3. And so remember how the fraction bar means division? A negative divided by a positive would be a negative, and that's why this ends up being negative 7/3. Now, if I start at the other point, if I would have started at the point in the bottom right-hand corner, then instead of going down and right, I would have to go, let me move this to the front. For some reason, this is not showing. I would have to go up, and then I would have to go, again, this is not showing. Let me quickly change the, make sure this is to the front so you guys can see this. So I'd have to go up and then to the left. So change in y over change in x, that's the definition of slope. I'm going up 7, left 3, so that would be a positive 7, and a negative 3, because going left 3 is negative 3. Now, remember how the fraction bar technically means division. A positive divided by a negative should equal a negative. And so this will also equal negative 7/3. This is a good time to now mention that a negative fraction, negative 7/3, is equal to negative 7 over positive 3, but it's also equal to positive 7 over negative 3. They all mean the same thing. Now, what it would not be equal to would be a negative over a negative. And you saw that on the first set of examples. If you have a numerator that's negative and a denominator that's also negative, that actually ends up equaling a positive, because a negative divided by a negative equals a positive. So this is a good box to star in your guided notes. When you have a negative fraction, that's the same as the numerator being negative or the denominator being negative, but not both. Okay? The most common way of writing it is putting the negative sign in front of the entire fraction, or leaving the negative sign in the numerator. You're rarely going to see textbooks across America putting the negative sign and leaving it in the denominator. It's just not very common to see that. And that's probably because we normally want to pronounce this as negative 7/3. It would be weird to call it 7 negative thirds, which is what you would pronounce it as if you had the negative staying in the denominator. So that's probably why, the most logical reason why you're going to see most textbooks leaving the negative to the left of the fraction or putting the negative in the numerator of the fraction. All right, let's move on. There are now 3 examples at the top of the next page, numbers 1, 2, and 3, that I want you to try on your own. You don't have to do it both possible ways of doing it. Even though I'm going to show you that here, both possible ways of doing it, you pick which way you want to start. So pick whichever point you want to start at. It's totally up to you. Hit pause on the video, do 1, 2, and 3 on your own, then hit play when you're ready to see how you did. All right, I hope you did these problems on your own, numbers 1, 2, and 3. Let's see how you did. If you started at the point up here on the top left, then you would have gone down 8, right 6. That makes it -8 over +6. Both of those numbers are divisible by 2, so this would reduce to -4/3. But if you started at the point on the bottom right, then you would move up 8 and then left 6. That would be a +8 over a -6, and that still is equal to the same fraction that I showed you before, -4/3. All right, problem number 2. If you started at the point at the bottom left, then you would have gone up 6, right 3. Both of those would be positives, and that reduces to the whole number of 2. But if you started at the point on the top right, then you would have gone down 6, left 3, and then those would both be negatives. And as we learned before, a negative divided by a negative would still equal a positive. And so it would still be equal to +2. All right, problem number 3. If you started at the point on the top left, you would go down 4, right 10. That would be a -4 over a +10. Both of those numbers are divisible by 2, and so this reduces to -2/5. But if you started at the point on the bottom right, then you would have gone up 4, left 10, and that would be a +4 over a -10. They're still both reducible by 2. And remember how I told you, it's very rare to keep the negative in the denominator, so I would still call it -2/5. Now, you might have noticed I did something a little interesting on this problem. I actually gave you another dot in the middle. And let me move that set of arrows away. If you just went down 2, right 5, well, then you get the -2/5 right away, don't you? And your fraction wouldn't reduce. So I did this on purpose to show you sometimes you can see more than just 2 dots on a line. And so if you can identify a dot that clearly exists on the line, then you might end up getting the same answer like we got here, -2/5, in a slightly different way of thinking of it than maybe somebody else in our class. And so you're still going to get the same answer no matter what. As you could see here, the fraction for the slope was -2/5, no matter which way that you counted here from one dot to another dot. All right, that would, it would even work from here to here. Again, down 2, right 5, that would still be -2/5. All right, let's switch gears and let's look at some real life scenario problems. Finding slope from word problems and possibly also from pictures. Problem number 4. Now this one's already done for you in your guided notes, but follow along as I read it out loud. Find the slope of the section of the roller coaster pictured below. All right, you can see that this is forming a triangle. What do we know about slope? Slope is defined as the fraction being the numerator having the change in y, and the denominator is the change in x. Which one would be change in y? Well, remember what I taught you earlier? The change in y is going up or down. So that would be the 56 feet. And the change in x would be going right or left. That would be the 42 feet. Now, if you were not using a calculator, you would want to reduce this fraction, and you'd have to figure out the greatest common factor. I already typed this up for you. The greatest common factor was 14, and so this reduces to 4/3. You do not necessarily have to show what you're reducing by because you guys are at the 7th grade or advanced 6th grade level. If you were, 5th grade level, you would definitely be showing what you're reducing by because that's when you first learn how to reduce fractions. But at this point in time, I'm not going to lose sleep if you do not show me what you are reducing by, like here we reduced by 14. And I fully understand some of you have a calculator that you are using today, and it has a fraction key which will therefore reduce fractions for you. So, another reason why you don't necessarily have to show what you are reducing by to reduce your fraction. But having said that, make sure your final answers are always in simplest form. All right, I want you to hit pause on the video, do problem 5 and problem 6 on your own. So hit pause on the video, do those 2 problems on your own, then hit play when you're ready to see how you did. All right, problem number 5. It said the slope of a road that rises 24 feet. Now let's keep this in mind. Slope is change in y over change in x, or as many algebra teachers will say, rise over run. So clearly then, the rising of 25 feet, that should be your numerator. That's your up and down. That's your change in y. Your denominator would be the 80 feet, the horizontal change, because horizontal would be the direction of x. Now, both 25 and 80, they have a greatest common factor of 5 for those of you not using a calculator, and so that would reduce to 5/16. Again, you do not necessarily have to show what you're reducing by. I'm not going to lose sleep if you didn't show that, but I do want you to show the work of what your original fraction was before you reduce it. That piece of work I should always see. All right, so that's the answer for number 5, 5/16. And problem number 6. In a stairway, the slope of the handrail is the ratio of the riser to the tread. Now, you might not even understand what the words riser and tread means. However, it sure seems interesting that the word riser sounds like rise, and we talked about how slope could be called rise over run. And so this should be a clear giveaway that your fraction, if you think of rise over run, is going to be the riser's measurement over the tread's measurement. Furthermore, the problem even says that it's the ratio of the riser to the tread. So the first part's the riser, that's your numerator. The second part's the tread, that's your denominator. So that's further proof that we need to do riser over tread for the setup of our slope. Now let's go ahead and plug in the numbers for those 2 different measurements. Which one was the riser? The 8 inches was the length of the riser, so that's your numerator. And the length of the tread was the 12 inches, that's your denominator. Is this in simplest form? No, it is not. We should already know anytime you have 2 numbers that are even, they're at least both divisible by 2, but actually 8 and 12 have a greatest common factor of 4. If you reduce both 8 and 12 by 4, you would get 2/3 for your simplest form. All right, moving on. 3rd page of your guided notes. We can actually use a formula, create a formula for finding slope. Follow along as I read this out loud. As you learned from the 1st page, the definition of slope is the change in y over the change in x. But when you find how much something changes mathematically, you're actually subtracting when you find out how much something is changing. And so therefore, with that in mind, we can create a formula for slope. And you can see there's actually 2 different ways of doing the formula. You can start with the 1s or you can start with the 2s. Now, we have seen subscripts before. When you have 2 variables that are the same kind of variable, but they're representing 2 different numbers, both of that same kind of variable. You might remember when we had a base 1 and a base 2 for the bases of a trapezoid, and so we called one of them B1 and B2. This is the same idea here. It's just a numbering system. This does not mean y times 2 and y times 1. No, 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 no. This does not mean exponents, because these are not on the top right-hand corners. These are the bottom right-hand corners of the variables. This is just saying there's going to be 2 different y's, there's going to be 2 different x's. And so if you take the idea of slope being the change in y, change means you're subtracting, so that's why we're going to subtract the y's. That's where this formula is coming from. And remember how the denominator is the change in x? Well, change means you're subtracting, so you're going to be subtracting the x's in your denominator. Do you see how this actually is coming straight from the definition of slope? I'm not actually recreating the wheel here, guys. I'm not making up something brand new. I'm applying the definition that we had on the 1st page. And understanding the word change mathematically means subtract, and that's where we can get these formulas from. The order of the subtraction won't matter as long as you do the same order in the numerator as you're going to do in the denominator. So if you're going to start with the first y in the numerator, you better start with the first x in the denominator. But if you're going to start with the second y in the numerator, then you better start with the second x in the denominator. Be consistent. Now, if you still don't understand what I mean by having two different x's and two different y's, let me make sense for you on this idea. Follow along. The formula above can be used for finding the slope of a line when you're given two ordered pairs. The first ordered pairs is what we call the x and the y with the ones, because it's the first ordered pair. But the second ordered pair is when we say the x and the y are the x2 and y2, because it's the second ordered pair, so it gets the 2's. So do you get it here? This is what I mean by having 1's and 2's. The 1's are coming from the x and y coordinate of the first ordered pair. The 2's are representing the x and y coordinate from the second ordered pair. You'll see even more of what I mean when we start looking at some examples together. Speaking of which, continue on your guided notes. Let's look again at problem number 2 from the second page. But this time I'm actually going to give you the coordinates of the two dots. So take a look at this graph. This graph should look familiar to you. This was problem number 2 at the top middle of the second page. But this time I'm telling you what this dot is. It is -5, -4. And I'm telling you what this dot is as well. This dot is -2, +2. And so remember how we originally just counted spaces and we went up 6 and then right 3, and then we made that to figure out that this would reduce to a slope being the whole number of 2. But we can use the formulas that I just showed you. And we can now use the ordered pairs that I gave you on the graphs. And instead of counting spaces and needing a graph to do this, I can just realize the first ordered pair is the x1, y1. The second ordered pair is the x2, y2. You guys know ordered pairs are always x, y. So x, y, x, y. First order pair gets the 1's. Second order pair gets the 2's. Trying to make sure this is as simple as possible for you to understand. And now we can use the formula. And we're going to kind of do formula substitute solve, which is a very similar process that we've already used this school year, where you start with the formula, you substitute the numbers in, and then you would solve. Although we're not really solving here, we're just going to simplify the fraction. So I guess that means I would say formula substitute simplify. So follow along with me. This one's already typed up for you in your guided notes, but follow along. Who was y1 and y2? Well, I'm going to highlight them for you. Whoops, didn't want to delete that. Wanted to delete the highlighting. There we go. All right, so y1 minus y2. Who was y1? That was the 2. Who was y2? That was the -4. So the numerator is the change in y, which means subtracting the y coordinates. So that would be 2 minus -4. I hope you now see where that came from. The denominator is supposed to be your change in x, which obviously means subtracting the x's. Who were the x's? x1 was -2. x2 was -5. So the denominator is where you subtract those x coordinates. So that would be -2 minus -5. Now, subtracting negatives looks not very pretty, does it? We learned earlier this year when we first did subtracting problems with positives and negatives, we learned that subtraction is the same as adding the opposite, something you've heard me say over and over again. So if I take 2 minus -4 and I make that adding the opposite, then that's the same as 2 plus +4, which you can see I did for you over here off to the side. -2 minus -5 is the same as adding the opposite, -2 plus 5. Now, you guys should know by now, I'm totally cool with you making it adding the opposite on the original work of your problem, right there in the substitution step. You don't have to do it off to the side. You can make it adding the opposite right here on your original work of 2 minus -4 and -2 minus -5. All right, so what does that give me? 2 plus 4 is 6. -2 plus +5, you subtract in your head. The positive has the bigger absolute value, so that gives you +3. And then 6 over 3 reduces to 2. Sound familiar? That's the same answer we got from graphing. So I'm trying to prove to you how this works, and so you can see the relationship of the formula to the way we used to do it by counting spaces from a graph. Now, you might remember that I had showed you up at the top that you could actually start with the second y and the second x if you wanted to, making it y2 minus y1 over x2 minus x1. That's actually the way that most algebra textbooks, for some reason, traditionally show it. I don't really know why they want to start with the 2's instead of the 1's, but a lot of textbooks do it that way. I want to prove to you that you're still going to get the same answer. So if you did it that way, then you would start with -4 at the top and -5 at the denominator because they're the second y and the second x, and then you would subtract by 2 and subtract by -2. Again, I already made subtraction out in the opposite for you. Like I said, instead of doing it off to the side, do it right there in your work. That would give you -6 over -3. A negative over a negative is a positive, proving to you this also would give you the answer of +2. So I don't honestly care if you want to start with the second y and the second x for your subtraction, or if you just want to start with the first y and the first x. I think it's simpler to start with the first ones because they're the first ones you see with your eyes in the ordered pairs. But that's totally up to you. Both ways will work. All right, let's look at one more example together. Again, this one's already typed up for you in your guided notes. Directions, we're finding the slope of the line that passes through the given set of ordered pairs. So you guys know ordered pairs are x, comma, y. That's why I would label this x and y. This is the first ordered pair, so this is x1 and y1. Second ordered pair, x, comma, y. But since it's the second ordered pair, it's x2 and y2. Believe it or not, labeling your ordered pairs might make it easier for you to do the substitution correctly, especially since this is a brand new formula for you. Now, when you get to Algebra 1 class next school year, maybe you won't need to bother labeling the ordered pairs. But for now, since this is brand new, that extra 2 seconds of labeling can make a world of a difference for you and make the substitution easier for you to do successfully. Therefore, making that extra 2 seconds of labeling totally worth your time. Just trying to give you practical advice here, guys. All right, let's go ahead and substitute. Who's y1? That's 5. Who's y2? That's -1. So it's 5 minus -1. Subtraction, you know, is the same as adding the opposite, and that's why it's the same as 5 plus +1. Denominator is x1 minus x2, so that would be the 12 minus the 2. Now, notice, I did not make that add in the opposite. Why? Because I don't need to. It's just 12 minus 2. All right? I want to work smarter, not harder. There's no reason to make this kind of subtraction become adding the opposite. So only make it add in the opposite when it helps you to make it add in the opposite, when there's negative numbers involved. All right, let's finish this off. 5 plus 1 we all know is 6. 12 minus 2 is 10. Both these numbers are divisible by 2, which reduces to 3/5. And again, this problem was already typed up for you on your guided notes, but I wanted to go over it with you to make sure you understood how this all works. At this point, I want you to hit pause, do number 2 and 3 on your own. Then hit play when you're ready to see how well you did. All right, I hope you already hit pause and did these on your own. Problem number 2. I would label it. Here's your formula. Let's substitute. This is what your substitution step would look like. Check your work, fix your errors if you need to. From here, simple subtraction. I don't need to make it out in the opposite, guys. It's bigger positive minus smaller positive in both the numerator and the denominator. No need to make it out in the opposite. So 4 minus 2 is 2. 9 minus 3 is 6. This reduces to 1/3. Problem number 3. I think it's helpful for you guys to label your ordered pairs, so that's what your labeling will look like. Your formula, still the same as it was before. Let's substitute. So we would have 1 minus -7, -6 minus 3. This is where I definitely would make subtraction become adding the opposite. So that becomes 1 plus +7, and this become -6 plus -3. And so that's going to give you +8 over -9 You might recall I said earlier in this lesson that we would rarely ever keep the negative sign in the denominator, so therefore I would recommend just calling it negative 8/9. All right, turning the page. Problem 4 and 5. Hit pause on the video, do these on your own. Then hit play when you're ready for me to go over it. All right, I hope you did that. 4, here's the labeling, here's the formula. Substitution step looks like this. Make subtraction, add in the opposite, and also here. That's going to give you negative 9 over positive 15. Both of these numbers are divisible by 3, reduces to negative 3/5. Problem number 5. Here's the labeling, here's the formula. Substitute, double check your substitution, make sure it's correct. Again, I would make subtraction adding the opposite whenever negative numbers are involved. So that becomes plus positive 3. This becomes plus negative 12. That gives you negative 7 over negative 14, because when you have a negative plus a negative, you add in your head. A negative divided by a negative, we talked about this earlier in this lesson, gives you a positive final answer, and both 7 and 14 are reducible by 7. So this reduces to 1/2. All right, these problems are getting very repetitive, which is why I'm now giving you the challenge problem of the day. Problem number 6. If a line passes through 2, 3 and has a slope of negative 4/5, write another possible ordered pair the line could pass through. So what I'm giving you this time is I'm only giving you one of the ordered pairs, and I'm giving you what the slope actually is. You have to come up with the second ordered pair, or maybe you could call it the first ordered pair if you want to, either way you look at it. You have to come up with another ordered pair that this line would pass through, given that it already passes through 2, 3 and has a slope of negative 4/5. Hit pause on the video, try this on your own, then hit play when you're ready for me to go over it. Okay, I hope you did this on your own. There's many different ways of doing this. One possible way is using the formula. You might be like, Mr. Underkoffler, well, how do I use the formula? We know the slope is negative 4/5. You can substitute that in for the m. But the substitution on the right-hand side is going to be a little interesting. We don't know. We have to come up with another possible ordered pair, another possible x and y. So that's going to stay variables. But we know the other x and y is 2, 3. 2 is the x, 3 is the y. And so if this now tells you, kind of gives you the hint that you needed on how you could do this problem, maybe you were stuck before, then hit pause on the video again and finish this up on your own if you now know what you could possibly do to get another ordered pair that this line could pass through. All right, from here, we can make two different equations. We know that the numerator, that y minus 3 has to equal negative 4, so that's where this comes from. We know that the denominator, x minus 2, has to equal 5, and so that's where this other equation comes from. And now you just have to solve the equation. What number minus 3 would equal negative 4? Well, you can use inverse operations on both sides. You guys know the inverse of subtracting 3, adding 3. That gives you negative 1 for the y. For the x, you might be able to do this one in your head. You can probably figure out the answer 7. But if you couldn't do that in your head, then you would add by 2 on both sides. Of course, that gives you 7. So what's the final answer? The ordered pair will be 7, negative 1. That's not the only way you could have done this problem. For those of you who are visual learners, you could quickly make a sketch and say, okay, 2, 3 is somewhere, up here on the top right, quadrant 1. If my slope is negative 4/5, remember slope is change of y over change in x. So if the change in y is negative 4, that means I would go down 4. And then if the change in x is positive 5, then I would go right 5. Now, think about this. If I go down, that's like taking 2, sorry, not 2. the y is 3, my bad. 3 minus 4. You're like, where'd you get the minus 4? The change in y is negative 4. Going down 4 is like subtracting 4. Well, what's 3 minus 4? Negative 1. Sound familiar? We already figured out the y was going to be negative 1 doing it the other way. If I go right 5 spaces, because the change in x in your denominator was positive 5, so that's right 5 spaces, then that's like taking the x coordinate of 2 and adding it by 5, because you're going to the right. That's like adding by 5, increasing by 5. And 2 plus 5 would give you 7. So that's another way of getting the exact same answer. Could you maybe do a hybrid where you just took 3 minus 4 and 2 plus 5 without drawing the sketch of the graph? Yes, I'm sure some of you at home might have done that on your own. Bottom line, you should do some kind of work. Math teachers always want to see your work. So your work doesn't have to look like my work on the right or my work on the left, but it has to look like something. You have to show some kind of work to show me how you got your answer. Now, by the way, this is not the only answer to this problem. 7, negative 1. Think about this. The line goes on forever. So instead of going down 4, right 5, I could reverse that and actually go up 4, left 5. So if I go up 4, then that would be taking the 3 and increasing it by 4, which would give you 7. And if I go left 5, then that's taking 5 away from 2, which puts you in the negatives. And so if any of you guys at home got the answer of negative 3, 7, that is another answer to this problem. All right, moving on. One last piece of your guided notes. I want you to understand that sometimes your slopes for your fractions are going to have a 0 in the numerator or the denominator. And if the 0 is in the numerator, that's actually very different than having the 0 in the denominator. Let's look at 2 examples that are already typed up for you in your guided notes. If I want to find the slope through these 2 ordered pairs, using the formula, subtract the y, so that's 14 minus 14, subtract the x's in the denominator, that's 5 minus 2. 14 minus 14 we all know is 0, 5 minus 2 is 3. Now, what does this mean? 0 over 3 means 0 divided by 3. And it just so happens that if you take 0 first, as your first number, then divide it by something else, that is always going to give you an answer of 0. And so 0 in the numerator over some other number, that kind of fraction, since it means 0 divided by 3, would simplify to a final answer of just 0. But in contrast to that, problem number 8, if I have these 2 ordered pairs, here's the formula. Subtract the y's would be 8 minus 2. Subtract the x's would be 14 minus 14. This would give you 6 over 0. Now this is different. 6 over 0 means 6 divided by 0. If you guys have a calculator with you, pull it out right now. 6 divided by 0. Punch it in that order. I guarantee you, your calculator is going to give you an error message because there are no amount of zeros that can actually ever make 6. Think about it. Can 0 ever make 6? 0 times 0 is 0. 0 times 1 is still 0. 0 times 5 is still 0. 0 times 6 is still 0. 0 times 600 is still 0. It's impossible for 0 to ever make 6. And that's why your calculator gives you an error message, because you can't divide by 0 and get an actual answer. It doesn't work. And so this is a very different answer than problem number 7. Since 6 divided by 0 is impossible to mathematically do, give you an error message in your calculator, the official answer for this mathematically is that there is no answer. It's undefined. Another way of saying this is that the slope, there actually is no slope. That's not the same as 0 slope. In fact, to put this into more terms for you to understand, 0 slope is when you have a flat horizontal line. No slope is when you have a straight up and down vertical line. So they're very different lines, and that's why these are very different answers for slope. You'll get into more detail about this when you get to Algebra 1. All right, now that you heard me explain numbers 7 and 8, I want you to do 9, 10, and 11 on your own. Hit pause on the video, do these 3 problems on your own, then hit play when you're ready for me to go over them. All right, problem number 9. All right, formula, substitute the numbers. That should give you 5 over 0. If you look back at problem number 8, when you have a number over 0, and if you try that in your calculator, you will get an error message. And so that's going to give you the answer of undefined or no slope. But problem number 10, when you use the formula, subtract the y's in the numerator, 13 minus 13 gives you 0. 4 minus 6 in the denominator gives you negative 2. 0 divided by negative 2, if you punch that in your calculator, you do get the answer of 0. All right, one more problem to go, number 11. Now, I gave this problem a little bit differently in format. Instead of writing you ordered pairs in parentheses, I gave it to you in a chart format like you saw on the previous guided notes that we had just done before this lesson. You could still do the formula. And you would substitute, it would look like this, 8 minus 14, 4 minus negative 1. You would make subtraction, adding the opposite in the denominator with that 4 minus negative 1. I'll go ahead and do that real quick, adding the opposite. And so that's going to give you negative 6 over 5. That doesn't really reduce, so it just stays negative 6/5. But there is another way you could have done this problem without using the formula. You could have said, how do I get from 8 to 14? How do I get from 4 to negative 1? Remember change in y over change in x, the original definition I gave you on the first page? Well, to get from 8 to 14, you would go up by 6, wouldn't you? But to get from 4 to negative 1, you would go down by 5. Do these numbers look kind of familiar to you? They should. It's kind of the same stuff we had over here, except this time it'd be positive 6 over negative 5, but we already learned a positive divided by a negative still gives you a negative answer, proving it's the same answer as we had before. I do not care which way you would do a problem like this. I want you to see different ways of doing the same kind of problem, and they both tie into the definition. Slope is the change in y over the change in x. That's the big idea that I want you to learn from this lesson. All right, guys, thanks for doing these guided notes with me. We'll see you next time.